Alright, this is my second video on Canigou. The first one, if you remember, was directed to Jeranism. This one is towards Taboo Conspiracy, who put out a video this afternoon, which is actually a mirror from a guy called indio007. And in that video, he is basically getting the refracted hidden of 1.7 kilometers with a distance of 277 kilometers and a viewer height of 946 meters. And trying to draw that 1.7 kilometers refracted hidden on the image, and therefore declare that anything below that level shouldn't be seen. But as usual, for flat earthers, they completely fuck up identifying the peaks, which is strange in this case because you've got these fairly prominent towers down here, and if you draw a line from your observer position through the middle of those towers, you can pretty easily figure out what that peak is, and they're not hard to find on Google Earth either. Alright, so let's identify the peaks properly. So this one here is not Canigou. This is called something French. This is not this French one. This is another French one. This one is Canigou. And the other two, which he has misnamed, this one in French, and that one something else in French. Alright, so now they've got that sorted, we can try and figure out what level this is here. So we've got the top of Canigou here at 2,784 meters, I think, and the horizon here. Now this line here is the geometric horizon for my render that I did in Povray, which I will fade in now. So as you remember, my ray tracer does not have refraction. So this horizon here in my ray traced image is purely the geometric hidden. So I'll just fade that in again just so you can see that it actually matches the image. Let's go again. Alright. Now, what we're going to do now is these measurements here are from the position of this line in PowerPoint. So if you took a screenshot of this video, you could use pixels. I'm using the measurement inside PowerPoint, and it's 4.47 centimeters. And that lines up with the peak of Canigou at 2,784 meters. This is the geometric horizon, so no refraction, which I get from my ray tracer. You can also get that number from the Metabunk curve calculator. And the position on that image in PowerPoint is 5.55 centimeters. This line is the horizon in the actual image, and according to PowerPoint, it is 6.56 centimeters from the top of the image. So we want to work out at what elevation this line is and how much of Canigou is obscured. And we can do that with some pretty simple maths. So we work out what distance is there between these two lines, both in centimeters and in meters. So there is 1.08 centimeters on PowerPoint between those two lines, and that equates to the difference between the geometric horizon and the top of Canigou, which is 572 meters. So we have a scale, and we can then use that scale to work out where this line is, where this intersects Canigou. So we have the horizon in the photo minus the top of Canigou, and we want to know at what height that is against Canigou. So there's 2.09 centimeters difference between these two, but how many meters is that? Given 1.08 centimeters is 572 meters, and it works out to be 1,107 meters. So we know that this line, the true horizon in the photograph, is at a height of 1,677 meters. So even now, flat Earth is gone. There is 1.7 kilometers of hidden, but notice how close this 1,677 meters is to the refracted hidden that you calculate in the Metabunk curve calculator. So the actual horizon in the photo is very, very close to the calculated horizon, or the calculated hidden amount in the Metabunk curve calculator under standard refraction. And also have a look at the difference between the geometric hidden of 2,212 meters and the refracted hidden of 1,703 meters. That's a difference of about 509 meters of looming. And if you plug that 509 meters of looming into the angular size calculator at a distance of 278 kilometers, it's only loomed up about 0.1 degrees. It doesn't need a whole lot. All right, but let's rub it in. So again, we've got the same two lines, the top of Canigou and the geometric hidden, or the geometric horizon. So we're going to use the same scale, where 1.08 centimeters is equivalent to 572 meters on the image. And we are going to find out where sea level is at Canigou on the image. So what we've got to do is work out, using the same gradient here, or the same equivalence, is to work out what centimeter position on the image is equivalent to 0 meters elevation. So we've basically got to add 5.26 centimeters to our peak of Canigou, and that gives us our sea level of 9.73 centimeters on that image. And where is that on the image? Way down here. So basically on the original photo, everything above that line is obscured by water. So thank you, Taboo Conspiracy, for looking. Hope you understand that this is a good proof of the globe. Thank you.